So we have to do the sixth question. Sixth question onwards we are doing. So that is this. So we have to find the intervals in which the functions are strictly
6.2.
6.1 only, right? This exercise
Okay.
6.1. We are continuing 6.1. So fifth question we did yesterday. 2x, I mean day for yesterday. 2x square minus 3. This one is done. So now we have to do for this function, we have to see whether it is strictly increasing or strictly decreasing for what intervals. So that is what we are supposed to do. The question is x squared plus 2x minus 5. F of x is x squared plus 2x minus 5. So we do the f dash x, then we get 2x plus 2. So now we'll have to see for what intervals this is greater than 0. So 2x plus 2, if that is greater than 0, that will be strictly increasing. If it is less than 0, that will be strictly decreasing. So now when we look at this, x is greater than minus 1, that is strictly increasing. For all x is less than minus 1, it is strictly decreasing. So if we have to write as an interval, then anything from minus 1, starting with minus 1, up to infinity, strictly increasing. So for infinity, we can't put a square bracket, we have to draw a curved bracket like that. So this is the interval. And for this, less than minus 1, that means minus infinity up to minus 1. So whether minus 1 is included, not included, then we have to put like this. Even this case also, minus 1 is not included. It is greater than minus 1. So both are curved brackets only. So this is the answer for the first question. That is A. This is A. B is 10 minus 6x minus 2x squared. So 10 minus 6x 10 minus 6x minus 2x squared. So when we do f dash x, so we will get this one as 0 minus 6 minus 4x. So now we
Okay,
have
sir.
to find out for which intervals. So minus 4x minus 6 is greater than 0, that is strictly increasing. Minus 4x minus 6 less than 0, that is strictly decreasing. So those are the intervals we should be looking at. So now for this minus 4x, you take the minus 4x to other side. That is the best one to do. So if I take the minus 4x to the other side, then I have minus 6 greater than 4x. So if you rewrite that, 4x is less than minus 6. X is less than minus 3 by 2. So x is less than minus 3 by 2 is for strictly increasing. Similarly, it will be greater than minus 3 by 2 would be strictly decreasing. So if you look at it, it will be if x is greater than minus 3 by 2, it is strictly decreasing. We can even stop it here. If you just write this also, you will get the marks. Okay, you don't have to say the interval or anything. So all real numbers greater than minus 3 by 2 will be strictly decreasing. Otherwise, it will be strictly increasing. So now we pick up next question. So this is C and D. So I'm
Yes,
just
sir.
going to cut this off and then put on to the next page. C and D. So So we got a very big one actually, bigger than. So minus 2x cubed minus 9x squared minus 12x plus 1. So we'll write that as f of x equal to minus 2x cubed, that is this one, minus 9x squared minus 12x plus 1. F dash x equal to minus 6x squared minus 18x minus 12. So we need to see for which intervals this is greater than or 0. So simply take out 6 common from here. We'll have x squared plus 3x plus 2. So first try to factorize this. Then we'll have minus 6 x plus 1 into x plus 2. So by the number line approach, we draw the number line and we'll just call, we need minus 1 and minus 2. So for example, this is 0, this is minus 1 and this is minus 2. So definitely at minus 1 and minus 2 it is 0. So we want to give some values between minus 1 and minus 2, between minus 1 and 0. So let's give, let's say x equal to 0. Then what happens? We'll have f dash x equal to 1 into 2 minus 6 into 1 into 2. That is minus 12. So this is negative. That means here it is negative. So anything greater than minus 1, this side, entire this side, it is negative. So that means it's strictly decreasing. So
Okay,
we
sir.
will see one more value, minus 3, outside minus 2. So let's say x equal to minus 3. Then we will have f dash x equal to minus 6 into minus 3 plus 1 is minus 2, minus 3 plus 2 is minus 1. So all together 3 minus are there, so you will have minus, and this is 12 again. So this is also negative. That means anything this side also, it is negative. So only positive here. So we have to write in such a way that the function is strictly increasing only between this interval, that means minus 2 less than x less than 1, less than x less than 1, minus 1. So this is where strictly increasing. For all other intervals, you don't have to write every, for other values of x, for other values of x, it is strictly decreasing. It is strictly decreasing. So that is what is the answer for the D. E, x plus 1 whole cube into x minus 1 whole cube. This is the question. So E f of x equal to x plus 1 whole cube to x minus 3 whole cube. So f dash x. Now question will be, what do we do? Do we do a product rule? How do we differentiate? This is u and this is v. You can do that way also. Or simplify this because both are cube only. So you will say that x plus 1 times x minus 3 and then put the cube for whole stuff. Then write this as x squared minus 2x. When you actually multiply, you will get minus 2x minus 3 whole cube. So this is better to differentiate this rather than UV rule. So you will have from this, so you will have 3 times of x squared minus 2x minus 3 whole squared times multiplied by chain rule for this. So you'll have 2x minus 2. So this is the total differentiation. That means 3 times of x squared minus 2x minus 3 whole squared into 2. I took the 2 common and we have x minus 1. So again break this like this. So that means 6 into x minus 1 into x minus 3. This is at x minus 1 into x minus 3. Both are square into x minus 1. That means you have got x minus 1 whole cube. So this becomes whole cube and it is not there. So this is what my f dash x is. So for this f dash x, we need to try. So I'm writing that f dash x again. So this is 6 times x minus 1 whole cube into x minus 3 whole square. So draw the number line again. So the two values are 1 and 3. So I'll put 0, 1, 2 and 3. I'll have to see this is the border 1 and 3. Okay, so you have some region and you have another region and you have another region. Three regions are there. So let's say x equal to less than 1. Let x equal to 0 because less than 1. So when I put 0, f dash 0 will be minus 1 whole cube is minus 1. 6 into minus 1 whole cube minus 3 whole square. So this is positive, but this is negative. So you will get minus 6, which is negative. That means here it is strictly decreasing. So between 1 and 3, so I'll give 2, f dash 2. So f dash 2 will be 6 into 2 minus 1 whole cube, 2 minus 3 whole square. So this will be 1 cube into 1, so 6 into minus 1 whole cube is minus 1, so minus 6. So here also it is negative. That means it is strictly decreasing here also. And let's see what will happen to the other one, 3. That means any value, I'll give 4 here, f dash 4. So f dash 4 will be 6 into 4 minus 1 whole cube, 4 minus 3 whole square. So this is totally positive because 4 minus 1, 3 cube is 27, 27, 6 into 27 into 1, which is positive. Therefore, strictly increasing. So, final, you have to sum it up and say the answer. F of x is strictly increasing for this positive thing. That means anything greater than 3. So, for x greater than 3. It is strictly decreasing for x less than 3. That's the answer for that. So we have done the C and E. C and E we have done. Oh, D we skipped. Okay, D is here. D we have done, no? 6 minus 9? No, we haven't done. We haven't done. Okay. So for this, f of x equal to 6 minus 9x minus x square. F dash x equal to 0 minus 9 minus 2x. So minus 9 minus 2x is greater than 0, strictly increasing. Minus 9 minus 2x is less than 0, strictly decreasing. So let's look at, we take 2 to the other side, that means minus 9 is greater than 2x. That means x is less than minus 9 by 2. So x is less than minus 4.5. This is for strictly increasing. And this one, so minus 9 is less than 2x. This is greater than, so greater than. So in this case, x will be greater than minus 9 by 2. So this is for strictly decreasing.
Okay, sir.
So now we will just say that strictly increasing for x less than minus 4.5. Strictly increasing for x. Wait a minute, what are we doing? I think I reversed it. It is strictly, this is not correct. This is reversed. So strictly increasing for this, strictly decreasing for this. For x greater than minus 4.5. So these questions are done. Now let's go back to the previous page. So we have done this, we have done this. All these things are done in the question number 6. So this kind of questions, now 7, 8, 9. These are more than 3 marks, no, rather 3 marks questions. Whatever you have, 7, 8, 9, and all the 3 marks questions. So the first one, so let's take the first one. So we have this entire thing. copy it and add to new page. So this is the page we are getting. So let's suppose, so this is a function y is equal to log 1 plus x minus 2x divided by 2 plus x, and see what he has given here is x is greater than minus 1. Why x is greater than minus 1 given? If you have x is equal to minus 1 here, let me show this. See, if you have x equal to minus 1, then log 0 it becomes. Log 0 is not there, it's undefined. That's why it cannot be minus 1. If it is less than minus 1, for example, it's minus 2, x is minus 2, then you get log 1 minus 2, which is minus 1. So there is no definition log negative log 0. Log 0 is not even 1, not these two are undefined. They are undefined. That's why this is greater than minus 1 is given. Why do we need this, first of all? Okay, next look at that. Why do we need that? He says we need to prove that throughout its domain. He's saying throughout its domain. What does it mean by throughout its domain? So the domain itself now is, the domain is the values of x. That is nothing but x greater than minus 1. He already said. So we need to be giving any value greater than minus 1 and try to find out. That's what is the question. So the remaining procedure is same. He says show that this function is an increasing function. So we just need to show greater than 0. It can be 0 some places. So we just need to say greater than 0. So it will be increasing. So we are taken now y is equal to 1 plus log 1 plus x minus, I'll be doing it at the bottom. Log 1 plus x minus 2x by 2 plus x. This is the question. So there is a notation also, I think we learned it, right? If you have f of x, then derivative is f dash x. Derivative or differentiation is f dash x. We also have a notation, y is given, we can write as a y1 or y dash. That means the first derivative. Okay, this also notation is there. That's why I will be using y dash equal to log differentiation is 1 by 1 plus x, and chain rule differentiation of this is 1 only, minus, now for this I have to use 2x by 2 plus x, I have to use the u by v rule. So u by v rule, if you remember that, u dash v minus uv dash divided by minus v squared. So I'm using that u by v 2 plus x whole squared. I'm just writing u by v rule. Okay. So 2 plus x whole square, u dash is 2, v is 2 plus x, minus u is 2x, v dash is just 1. So this is what we need to be simplifying. So y dash equal to 1 by 1 plus x minus, in this you have 2 plus x whole square and 4 plus 2x minus 2x. So this plus 2x minus 2x gets cancelled. So then we have 1 by 1 plus x minus 4 by 2 plus x whole square. So this is y dash. So we have to see for what values, or forever it is increasing only. That is what we need to be doing. So he said x has to be greater than minus 1. Our domain is x greater than minus 1. So number line, if you draw, there is a minus 1 and there can be 0, it can be minus 0.5 also, and many values are below this, between this. And you can have a 0.5 or it can be 0.7 or whatever, 1 and then 2, like that. So we need to see first of all Since it's greater than minus 1, let us give equal to minus half. That's a 0.5. So then y dash becomes 1 by 1 minus half minus 4 divided by 2 minus half whole square. So then we have this here. 1 by 1 minus half is 1 by 2. So we get 2 for the first one minus 4 divided by 2 minus half is 3 by 2. 3 by 2 whole square is 9 by 4. So you have 2 minus 16 by 9. That's equal to 2 minus, so 9 ones are 9, 1, 7 by 9. So 2 is greater than 1, 7 by 9. Therefore, you get y dash is a positive. So for minus zero point 0.5 you got positive, and you can try for y dash 0, x equal to 0. Then you have y dash is nothing but 1 by 1 plus 1 by 1 plus 0 minus 4 divided by 2 squared. This is equal to 1 minus 1. So 1 minus 1, isn't it? 4, 1 by 4. This is equal to 0. So at x equal to 0, y dash is 0. What this means, so when you actually look at f of x, and if it is a minus 1, so minus 1, 0, it is increasing, rather f dash x. It's increasing, it's a positive here. And suddenly it became 0 at this place, okay? And again it will be increasing. So if you remember the graph, if there is some flat thing, then we say y dash is positive for some intervals. It is 0 also. It is 0 at some point. Therefore, it is not strictly increasing but increasing. Therefore, it is just an increasing function, but not strictly increasing function. This you don't have to write. This part you don't have to write, but this is what he asked us to prove. Okay. Now I'll be saying this okay and all just to make sure that I mean the network is cut or something like that. That's the reason. You was there, right, Sam?
Yes, sir. Yes, sir.
Yeah. Only for that reason I'll be saying. Otherwise, yesterday same thing happened. I kept on talking, and then that boy didn't respond, but he's online. He's there on the Zoom. He's not responding to my chat. He's not saying yes or no.
Sir, there's some problem. There's some problem in my internet. There's a huge delay between you talking and me talking.
Oh, okay. No, no, no. Just say yes, that's sufficient. Even just you press that, unmute, I will hear that sound, right? Then I know that you are there. Okay? Yeah. So,
Yes,
going,
sir. It takes like 10 seconds for me to.
hmm, I got it. Got it. Yeah. So find the values of x. I'm doing the eighth question. Find the values of x for which y is x into x minus 2 whole squared is an increasing function. This is the one we are doing. So y is, so this is the one. Okay, so this is the one I'm doing. Y is x into x minus 2 whole square is an increasing function. We need to find the intervals. So again, I'll take this entire thing x into x minus 2 whole square. So I'll draw it here. I'll draw it here, and I'll put it here. Eighth question. Y is equal to x into x minus 2 entire whole square. We need to find interval. Find interval for which it is an increasing function. It is an increasing function. So I take this, but I would like to just make sure that this is separated from here to here. I will just draw one more line again. And so now open this bracket. It's better to open this up and then you differentiate. So y is equal to x squared minus 2x whole squared. So now when we do y dash differentiation, 2 into x squared minus 2x with the chain rule, multiplication of differentiation of this, you get 2x minus 2. So take off 2 common from this, you get 4, and you have this one broken down back, x into x minus 2, and this is x minus 1. So we have this as a y dash. So I'm sure you understood this part, x into x minus 2, and this is the 1, 2 taken out, and that's why entire x minus 1. So now we clearly know that there's a 0 part, this is x equal to 2, this is x equal to 1. So 3 points we need to mark on the number line. 3 points we mark on the number line and check whether it's increasing or decreasing. So 0, 1, 2. So we have a region something left side of this is one region, and this is another region between this and this, and between this and this, and between this and this. 4 regions are there. So let's give a value something like minus 1. First we say y dash at minus 1, x equal to minus 1. Then y dash is equal to 4 into minus 1 into minus 1 into minus 1 minus 2 minus 3. This is minus 2. So 3 minus are there. Definitely this is negative. 3 2s are 6, 6 4s are 24, minus 24. So it is negative. That means it is decreasing. So x equal to minus 1 decreasing, that means this is decreasing here. Or you can say strictly decreasing also. Now between 0 and 1. So we want to try y
Talk
dash.
to you. So,
Okay. So So 0 and 1 is a zero point 0.5. So I'll give half. So y dash equal to 4 into half. And then half minus 2 is minus 3 by 2. And then half minus 1 is minus half. So this is definitely positive because 3 by 4, 4, and 4 gets a half. So we have plus half. So at this is positive. So this is increasing. Next, between 1 and 2, I'd like to give a 1.5. Y dash at x equal to 1.5 or 3 by 2. 3 by 2 is for this region. So then y dash equal to 4, 3 by 2. Then 3 by 2 minus 2 is minus half. And 3 by 2 minus 1 is plus half. So you are getting negative, negative 3 by 2 something. So here also actually plus 3 by 2, not half. So this is negative. So I'm getting this is to be decreasing. So obviously this will be increasing, but let's check that. Y dash at 3, x equal to 3, which is this region. So y dash is equal to 4 into 3, 3 minus 2, and 3 minus 1. So all positive. So you'll get 12, 12 into 1, 12, 12 into 2, 24, positive 24. So this is positive, that means this is increasing. So this interval and this interval, two intervals are required. So in answers, what they expect for this kind of a question is, so we have to say between 0 and 1. So just say it is increasing in the interval, in the interval. The first interval is 0 less than x less than 1. Then we write something, we put this in a bracket, without bracket also, I think, right? And we'll say union. Union means there is one more, that's this one, x greater than 2. So this is how they expect the answer with the union symbol. Okay, so this interval and that interval. We can't write and also. Okay, so you just have to write this is a notation. Right. And looking, maybe you have sent a WhatsApp again. No, no. So I'm going up to this question is done. Now we have to do the ninth question. That is this. Prove that y equal to 4 sine theta divided by 2 plus cos theta minus theta is an increasing function throughout its domain. I'm sure you'll just say, oh, he says between 0 and pi by 2. Look at that, he has used square brackets. That means including 0 and including pi by 2. So including 0 pi by 2 interval, this is to be an increasing function. That's what I should be. 4 sine theta by 2 plus cos theta minus theta. So I just need to be 4 sine theta by 2 plus cos theta. So this is a function and the interval is 0 to pi by 2. We need to show it is increasing. We need to show that it is increasing function. So y dash as usual, but let us see anything else we can do to simplify this. No, I don't think we can simplify. We have to use u by v rule. So first one, y dash. This is a long question. That's why I said these are the 3 marks questions. So y dash equal to, this is the u by v rule, 2 plus cos theta whole squared. U dash is 4 cos theta and v is 2 plus cos theta minus u is 4 sin theta. V dash is minus sin theta. So this is the first part differentiation is done. Second part differentiation is minus 1. For this it is minus 1. So now simplifying this, you get 8 cos theta plus 4 cos square theta minus into minus plus, you get 4 sin square theta here, divided by 2 plus cos theta whole squared minus 1. So 8 cos theta plus, this is 4 into sin square theta plus cos square theta. So 4 cos square theta plus sin square theta divided by 2 plus cos theta whole squared minus 1. So this 8 cos theta plus 4 divided by 2 plus cos theta whole squared minus 1, and take 4 common from this, you will have 4 into 4 taken 2 cos theta. Did I write it 2 plus cos theta, 2 plus 2 cos theta? So 4 sin theta divided by 2 plus cos theta. 4 sin theta divided by 2 plus cos theta. I think I written correct only. Okay. So if I take 4 common, I have 4 cos theta plus 1 divided by 2 plus cos theta whole squared minus 1. This is my y dash. So between 0 and pi by 2, that is what is my interval. So whenever they give inclusive, that means the square bracket, first try y dash 0. At 0, what's the value? Then you will have 4, 2 cos theta, cos 0 plus 1 divided by 2 plus cos 0 whole squared minus 1. That's equal to cos 0 equal to 1. So 2 plus 1 is 3. 3 fours are 12 divided by cos 0 is equal to 1. 3 square equal to 9 minus 1. 12 by 9 minus 1. So 12 by 9 is definitely greater than 1 anyway. So 3 3s are 3 4s are. So 1 by 3 minus 1, which is 1 by 3, which is positive. So it is positive at the lower limit. Now let's look at the upper limit. Y dash pi by 2. So you get 4, 2 cos pi by 2 plus 1 divided by 2 plus cos pi by 2 whole squared minus 1. So cos pi by 2 is 0. So that's why you get 4 divided by 4 minus 1. So we have 0. So as we said, right, if it is completely greater than 0, then we say strictly increasing. So even if it is 0, it is increasing function, but we need to make sure some other value in between 0 and pi by 2. Let us take pi by 3, x equal to pi by 3. So this is between 0 and pi by 2. So y dash pi by 3 equal to 4 into 2 cos pi by 3. Pi by 3 is 60 degrees plus 1 divided by 2 plus cos pi by 3 whole squared minus 1. So cos 60 is equal to 1 by 2. So 1 by 2 gets cancelled. So you get 1 plus 1, which is 8, divided by, so 2 plus 1, 3, you have 9 minus 1. Did I do correctly? So 4, 2 cos 60 is equal to 1 by 2. So 4 2s are 8. And this 1 by 2, oh, this is not 9. This is 1 by 2. So 2 and a half. 2 and a half is 5 by 2. So 25 by 4. This is not 9. This is 25 by 4. 25 multiplied by 4. So that means 32 by 25 minus 1, which is 7 by 25. So it's still greater than 0. Therefore, f of x is increasing in the interval, in 0 pi by 2, like this. Okay. So I will just pause for a second to allow you if you have any questions or anything.
No, sir, I don't have any question.
Okay, then fine. I will be going to the next part of it. That's, let me first go to the first previous page, and I have to pick. So we have done 8 also. So 8 is done, 9 is done. So we are now moving on to the question number, the entire page, next page. This is what it is: 10, 11, 12, 13, 14, the 20 of questions, all exactly same thing. We'll be doing exactly same thing for all of them. So prove that logarithmic function is strictly increasing on 0 to infinity. Second, 11th question, I will do them after I read it. So 11th one is prove that the function f given by f of x is x squared minus x plus 1 is neither strictly increasing nor strictly decreasing on minus 1 to 1. Okay? So we need to be checking this. What does he mean by neither strictly nor neither strictly increasing nor strictly decreasing? And which of the following functions? This is all trigonometric up to, and two questions are trigonometric. And then we need to find the value of a. So like that. So the first one we are picking up is prove that logarithmic function is strictly increasing over 0 to infinity. I just want to see whether this goes here. Okay, then I'll have another page. So we go back to this. So next page. Yeah. So question number 10. Prove that logarithmic function is increasing for x belonging to 0 to infinity. So this is the question. So let's see whether log 0 also is that only, right? So previous. So strictly increasing. Yeah, right. So, so we have to consider, let f of x equal to log something. You have to just say whatever, um, you can just say log g of x. This can be anything. We just say g of x is greater than 0. That is only the condition we are considering. Because if it is less than 0 or equal to 0, it is not defined. Now what we will do, f dash x equal to 1 by g of x and chain rule. The differentiation of g of x is g dash x. So we have f dash x is g dash x by g of x. So now we'll have to apply the conditions for x, such a things, such a value on all the stuff. Okay. So g of x is greater than 0, meaning whatever is the value, but we will take first verifying g of x for 0 and infinity. And we have to do the same thing, g dash x for interval 0 to infinity. Then totally we'll know what f dash x is. So for this first, let's give anything greater. That means let's say x equal to 1. So g of 1. Since we said any value of x which is considered greater than 0, so g of 1 obviously greater than 0. G of 2 also will be greater than 0. G of anything you'll give greater than 0 for this. So the denominator is greater than 0. Now for g dash x is differentiation of this. So when g of x is greater than 0, g dash x has to be greater than 0. That's why we'll assume that g dash x is greater than 0 provided g of x is a function differentiable. That's how we just have to write. I will tell you two methods. One is, this is a little complicated method. That's what we are doing. So since numerator and denominator of f dash x are greater than 0, we infer that f dash x is greater than 0 for all values x belonging to 0 to infinity. Therefore, f of x is an increasing function in 0 to infinity. This is the domain. So what is the other method? That's what we are trying to do. So the second method, simply you assume f of x is equal to log x. That's it. We are not complicating with f of x or anything. It's just g of x or anything. Let f of x is equal to log x. Then f dash x equal to 1 by x. Now f dash 1 is 1 by 1, which is 1. And you give f dash 2 will be 1 by 2. So f dash 3 will be 1 by 3. So I can only give anything between 0 and infinity. So greater than 0 only I have been giving. So we can infer that, that implies that f dash x is greater than 0 for all values of x belongs to 0 to infinity. Therefore, f of x is an increasing function. That's all. This is the second method. You can write this way also. Then we have to now go back and do the next question. So let's draw the line for this, and we'll go to the previous page, and previous page. So prove that this function is neither strictly increasing nor strictly decreasing. That's what is the 11th part of it. So I take from here. No, no. So take this question, add to a new page. So f of x is this. This is what we are trying to see. So f dash x equal to 2x minus 1. Now he's asking this is the interval. So the interval we are looking is minus 1 and 1. That means we should not include this or this. So let x equal to something, let x equal to greater than minus 1. Say x is equal to minus half. Then f dash minus half equal to 2 into minus half minus 1, which is minus 2. It is right now decreasing. So whatever I give here, it is decreasing. And let's give x equal to 0. F dash 0 equal to 2 into 0 minus 1. That's equal to minus 1. Still it is decreasing. Then we try to give something less than 1, and I'll say x equal to half. So f dash half equal to 2 into half minus 1. So this is 1 minus, understood, right? 2 into half. So this gets cancelled. 1 minus 1, which is 0. So as we said, right, it is decreasing, and then we have this, and let's see one more value, x equal to 1 by 2, 3 by 4. Let's give 3 by 4. Then f dash 3 by 4 will be 2 into 3 by 4 minus 1. So this will be half. So this is increasing. See, it is both are happening. That means in this interval, in minus 1 to 1, minus 1 to 1, f of x is decreasing, 0, and increasing. Therefore, we say it is neither neither strictly increasing. In fact, it is strictly decreasing and strictly increasing. Okay, 0, 3 are there, nor strictly decreasing. This is how we infer that. Okay. So done this question. So which of the following functions are strictly decreasing on 0 to pi by 2? And you have cos x, cos 2x, cos 3x, and tan x. So 3, let's see as many as we can do today. Cos x, cos 2x, 0 to pi by 2. So we go to the next page, and let me try to take this. And this is the one we have done. We put it here. So we are now trying for f of x equal to cos x, f of x equal to cos 2x, and that is 0 to pi by 2, right? So yeah, sufficient. I mean, that much is sufficient. You just made some noise. I know that you are there. So 12th question. So f of x is equal to cos x, f of x is equal to cos 2x, and f of x is equal to, so this is the first one, and this is the second one. So not strictly decreasing. If you see the question is, which of the following functions are strictly decreasing? Actually, are strictly decreasing. So strictly decreasing, okay, between 0 and pi by 2. So first one, f of x equal to cos x. Then we have f dash x equal to minus sin x. So 0 to pi by 2, we are not including this. So let's take a 30 degrees value, x equal to 30 degrees. That means f dash pi by 6 will be minus sin pi by 6. This is minus sin 30. So it is minus half. Then we give something lower than that. That means f dash 60 degrees pi by 3. Then we'll have minus sine pi by 3. That's equal to minus root 3 by 2. So this is strictly decreasing, right? This function is strictly decreasing. Let's see. Because you've got everything negative values. So which of the following functions are strictly decreasing on 0 to pi by 2? Okay. So definitely cos x is strictly decreasing. So this is the one we already give. Now we'll try for cos 2x. So we just say it is strictly decreasing in 0 to pi by 2. It's done. So the next part is, so I'm just trying to get the boundary here. So that's it. Boundary is done. So the second part is f of x equal to cos 2x. So f dash x is minus sine 2x multiplied by chain rule 2. So we'll have minus 2 sine 2x. So now we are trying same thing, f dash pi by 6, that's equal to minus 2 sine 2 into pi by 6, that's a pi by 3, minus 2 sine 60, that's equal to minus root 3. It is negative. Then f dash pi by 3. So then we have minus 2 sine 2 pi by 3. 2 pi by 3. So 2 pi by 3 is 360 by 120 degrees. 120 degrees. So minus 2 sine 120 degrees. So 120 degrees is in the second half, that will be out minus 2 into root 3 by 2. So you will have again minus root 3. Okay, how come both values same thing? This is 2 pi by 3. That's also 2 pi by 3. Yeah, correct. Both same value. And therefore, this is also strictly decreasing. So cos 2x is strictly decreasing as well. F of x equal to cos 2x is also strictly decreasing. Done. Then let's try cos 3x, and there is a tan x also. So third part, f of x equal to cos 3x. So f dash x equal to minus sine 3x into 3. So f dash x is minus 3 sine 3x. So we are trying with the pi by 6, which is 30 degrees. So minus 3 sine 3 into 30 degrees, that's equal to minus 3 sine 90. That's equal to minus 3. So negative. F dash pi by 3, which is 60 degrees, minus 3 sine 3 into 60 degrees. This is minus 3 sine 180 degrees. That's equal to 0. So definitely this is not strictly decreasing because of this 0. Therefore, f of x equal to cos 3x is not strictly decreasing. So we have done that part as well. So I just forgot what is our last one. Is it tan x? Tan x. D is a tan x. So tan x, fourth one, f of x equal to tan x. F dash x equal to secant squared x. So the moment you get square, it's a positive. So anyway, we'll try f dash pi by 6, which is 30. That means secant squared 30 degrees. Secant 30 is 1 by cos 30. Cos 30 is root 3 by 2. So 2 by root 3 whole square. That's a 4 by 3. This is greater than 0. Then if you try f dash pi by 3, it's 60 degrees. Secant squared 60 degrees. That is 2 whole square. This is 4. So all positive. Therefore, f of x equal to tan x is not strictly decreasing over 0 to pi by 2. So much we have done for today. I hope you understood. So I will,
Yes, sir.
yeah, I will send. Did you see the previous last night I uploaded YouTube?
Yes, sir. Yes, sir.
Yeah, but in that voice is clear, no? There you are able to hear clearly everything, right? No problem.
Yes, sir. Yes, sir.
Okay, okay. Then I'm stopping the recording first. I am stopping the recording and then